Today we're going to start looking at some familiar functions, specifically linear and quadratic ones, and some properties we can recognize with those. That way when we go to some new functions, cubics, quartics, and other polynomials, we can maybe extend our ideas we've already determined here to something new. Before we start that, let's just review a little bit how to graph these things pretty quickly or find out some interesting things about them. A linear function takes the order y equals ax plus b. We might remember this as mx plus b, but it's exactly the same thing. And a is our slope, b is our y-intercept. Those are the two basic properties for a line. You want to know where it starts and where it goes from there. To graph these quickly, we always start the y-intercept. Okay, so if we look at the first one here, we'll do this as we do our ideas. The y-intercept is this value at the end over here, the b value. Okay, that's my starting point. It's where I cross the y-axis. On my graph, the y-axis is the vertical one. So I know my line is going to cross there at -2. So I can draw a dot there. To get a line, I need another dot. I already only need 2 dots because if it's a straight line, it has to go through those 2 dots, right? So to do that, I'm going to use my slope. My slope is this piece right here. Slope, remember, is rise over run, or in our case, 3 over 1. Now we always say the top tells us whether to go up or down. It's a positive, so we can go up 3. And the bottom always tells us how far to the right we go. Okay, so 3 up and 1 to the right. So let's count from our dots we already made. 1, 2, 3, over 1. If we wanted to keep doing this pattern, 1, 2, 3, and over 1, 1, 2, 3, and over 1. But as I said, we only really need 2 straight lines. That was a little crooked, so draw a little straighter. Okay, and there is your line. Okay, nice and quick. And the line goes up to the right, and we can tell where it crosses. We can figure some interesting things out about that line if we needed to. If we try the second one, our y-intercept this time would be 4. Remember, that's where we cross the y-axis. 1, 2, 3, 4. From there, we're going to go a rise of -2 and a run of 3. The negative's telling me to go down this time. Again, the bottom always goes to the right. So I'm going to go down 2, 1, 2, and over to the 3 to the right. Make a second dot. Now this time I can't fit any more on the graph. I go off the graph. I can sort of estimate, I guess, one would be about there. But as I said, I only really need 2 dots to make a straight line. And if you had a ruler, you should use a ruler, as I obviously didn't. Okay, there's lines, and they're nice and quick. Not a whole lot we can do with them, but there are some properties we'll talk about later. Okay, let's take a look at quadratics. Grade 10, grade 11, we spent a lot of time with quadratics when we looked at different forms. Today we're going to look at the one we're going to use the most, the factored form. Okay, factored form is this thing up here at the top. Y equals a bracket x minus s and x minus t. Okay, there's 2 really important things there. A, it's the direction of opening. Okay, and the key here is if it's positive, it opens up. Okay, and s and t are the zeros, also called the x-intercepts. And the one thing you have to be careful about there is you have to change your signs when you take them out of the brackets. Okay, and we'll do an example here in a second, and we'll talk about why that works. Okay, but those are 2 important things we can tell by just looking at the equation. If you remember quadratics, sort of like this, like this. Okay, knowing our zeros is kind of helpful. It's these 2 points. Okay, the other most important point we want to find often is this point down here. We call it the vertex, the point where we change direction. To do that, we can find our axis of symmetry, which is the imaginary line that goes right down the middle of that parabola. And it's always halfway between our zeros. So the reason we like this factored form here, s and t, is if I know my zeros, I can add them together and divide by 2, and I'll get the axis of symmetry, which would be the x part of this coordinate right here. And to figure out the y part, hey, I can use my function notation and get the y that goes with it, right? Plug it back in, see what happens. Hey, we're going to try some right here. Just remind ourselves of how this stuff works. Okay. So, look at this first example. I want to determine the following. I want the direction of opening. We said the direction of opening comes from that value. If it's positive, which it is, positive 3, that tells me this opens up. And it's the sign that matters, not the number, the sign. Positive is up. Hey, what are the zeros? The zeros are -4 and 0, and 3 and 0. And a second ago I said, remember, change your signs when you take it out. And the reason why is, if I were to plug these back into the brackets, let's say I took -4. -4 plus 4 makes 0. That's why we call it 0. If I put 3 in the other bracket, 3 minus 3 makes 0. And again, that's why we call it 0. If I put it back in and it does not come out to 0, that means it's not one of the zeros. It has to make a 0 in order for it to be called a 0. Okay, our axis of symmetry. We're finding an x, the imaginary line. It goes halfway between our zeros. So we take our zeros, we add them together, we divide by 2, we come out to -0.5. And to find our vertex, the y part, we take the equation that we've been given, our function, and we replace the x's with the axis of symmetry, because that's the x part of the vertex. Okay, and then we evaluate our function here. So 3 times 3.5 times -3.5 comes out to -36.75. Okay, so at the end down here, move down just a little bit, our vertex is -0.5, the x, or the axis of symmetry, and the y. And there's our equation. Okay, you guys want to try the second one? Give it a try right now, see what you can do. The same properties, same ideas. Which way is this one open? Well, it's a -2, which means it opens down. Our zeros this time are 3 and 0, and 2 and 0. Our axis, we'll add them together, divide by 2, which gives us 2.5. And all I need is a y value now for the vertex, because I've got the x. I just calculated that. Plug all these things in the right spots, do some bed mass here. And that comes out to 0.5. So our vertex, I like to call it V, just so I know what I'm talking about here, is 2.5 and 0.5. Yeah. Hopefully you guys got those ones okay. Okay, we're going to do this a page at a time today because it's a fairly lengthy lesson, just so you can pause and go back if you need to.